Alright, so as I said we would do today, we're just going to go one step further with our covalent bonding. And the stuff we talked about last week, hopefully if you can remember, we talked about covalent bonding being sharing of electrons, but I guess sharing is one way to think about it, but it really is, it's actually overlapping. That's how you spell. Is it one P or double P? Overlapping? What is it? One, that's good to know. Okay. So it's overlapping of the orbitals. Okay. In this case here, the electron shells. Alright, now, the only chemicals we need to be aware of, or the only elements we're talking about now, because it's covalent, non-metal, are all of the non-metals. So we can get rid of basically virtually half of the periodic table, because these metals, they don't actually apply, okay? So we use those in ionic bonding. So these are the only elements we have to actually now work with in terms of structural formula. It doesn't look like many, but believe me, it gets fairly complicated. All right, now, the valency for hydrogen is 1. We went through that last week. So hydrogen's got 1 electron inside a shell, wants to get 2. So wherever I draw hydrogen in a structure, it's going to look like that. It's got to have 1 shared pair. Boron 3, we'll talk about that later. That's a bit strange. It's only got 6 in inside a shell. Carbon is 4. The nitrogen's valency is 3. Oxygen's 2. Fluorine is 1. So we worked that out last week, if you recall, about the number of electrons that it needs to get a filled outer shell. Okay, silicon, same group, that will be 4. Phosphorus, now I'm going to put down all the possible valencies for phosphorus. We'll talk about that one again later. But at the moment we're going to say phosphorus will be 3, so if I draw phosphorus, it's always going to have 3 bonds in its structure. Sulfur is 2, 4 or 6 is the valency. Again, we'll talk about 4 or 6 later. And fluorine is 1 or 7. And we'll talk about the larger numbers later, when we talk about more about the expansion of the octet. Alright, what does that mean? Well, you've got to remember all these valencies. That's all you need to worry about. That's it. So every time you are working with chlorine in a structure, it's going to have 1 bond in it. Every time you're working with sulfur in a structure, as far as you're concerned, it will have 2. But sulfur can also have 4 of them, okay? And sulfur can also have 6 bonds, but we'll talk about those again, like I just said, a little bit later. So whenever you're doing structural formula, that's what you have to remember. Everyone cool with that? So the valency number is what you have to have in your head. Okay? And you can work that out from where they are in the periodic table. Alright? Now, Joan, can you be quiet while I'm doing this? Alright, in terms of the formulas, and we'll look at a few examples. And we've done some of these already, but I'll now look at some more of the complex formulas. So, let's, for example, if we did say H2SO4, and I asked you to do a structural formula for sulfuric acid. Okay, the general rule for all the formulas that we're going to be doing is, and this is just basically just through doing it after over many years, pick on the element, Connie, you watching? Pick on the element with the greatest valency first. Because that one's normally going to be in the middle of the molecule. That's my suggestion. Okay? Now, you would have learnt this by now. Hydrogen's got a valency of 1, sulfur's got a valency of 2, 4 or 6, and oxygen's got a valency of 2. Okay? So therefore, I'm going to start with sulfur first, because it's got the greatest valency. Alright, then, I've got to get 2 hydrogens and 4 oxygens somehow in that structure. And this one here will end up looking something like this. And it is what we call expansion of the octet. I just said a minute ago I wouldn't go through it, but there you go. I've probably chosen one of the most complicated molecules to do first. Alright, so sulfur in this case is forming 1, 2, 3, 4, 5, 6 bonds. The oxygen here is forming 1, 2. This oxygen 2, this oxygen 2, this oxygen 2. So we've satisfied the number of atoms in the structure. And we've also done the valency for each of the elements. They're all correct. Everyone cool with that? Alright? Happy? Good. Even Dallas is school, not even in class. Alright, so when they ask you to do, like in question 35, I'm looking at it on page 111, when they ask you to do Lewis diagrams, electron dot diagrams, I always find it easier to do the structural formula first and then work backwards, okay? So I'll just do a couple from question 35. So phosphine has got the formula and they tell you phosphine is PH3. There it is, okay? So I've got to have phosphorus, how many valency, what's its bond? It's 5 or 3? Well, obviously here's going to be 3. So I'm going to draw phosphine first. It'll be 1, 2, 3. There it is there. Not knowing what the shape of phosphine is yet, but we're going to come to that in the next few lessons. So that's phosphine, and I have to now transfer it to a Lewis diagram. So I'm going to leave the elements where they are in three-dimensional space. Okay, and you can do it like this, and I will. I'll do the outer shell sort of idea, if you wanted to use that one. Okay, now phosphorus. Phosphorus has got 5 in its outer shell, doesn't it, Connor? Yeah. Okay, so I'm going to put 1, 2, 3, 4, 5. The trick is, 2 of them aren't used in bonding for phosphorus. Okay? So that's the phosphorus electrons. And I know that the hydrogen have all got 1 electron. That's a hydrogen electron there and there. And that's it. So what I've done is, phosphorus has now got 1, 2, 3, 4, 5, 6, 7, 8 in its outer shell. Okay? Each of the hydrogens has got 2 in its outer shell. That's the Lewis diagram, and we're only worried about outer shell electrons. And so as you can see, alright, they've all got filled outer shells now. It's all stable. So that's my suggestion when you're doing structural to the Lewis diagram. Do structural first. Don't go from here to there. Go from here to there. It's much easier to do structural formula first. Hayden, which one you want me to do next? Silane. Which one? Silane. SiH4. Cool. All right. SiH4. So same deal. SiH4. So when I'm drawing it, I've got the idea. All right. So silicon's got a valency of 4 because I've learnt that. That's on my shortened version periodic table, and I know hydrogen's got a valency of 1. So silane will be the same sort of idea. Silicon in the middle, and it's going to have 4 hydrogens around it. We're not doing it in the right shape yet. Okay? So there's the silane. I'm going to do the same thing. This time I'm going to get rid of the circles. So I'm going to go one step further. And I've got a hydrogen here, 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 and here. And I know that the silicon's got how many in the outer shell? 4. So I'm going to go 1, 2, 3, 4. And of course those electrons are between the atoms. Are you watching? And here is the electron from the hydrogen. Here's electron from the hydrogen. Next one and next one. So the silicon now has got 2, 4, 6, 8 in its outer shell. And each of the hydrogens has got 8 in its outer shell. That will be the electron dot structure or the Lewis diagram for silane. Happy? Okay, what else are we doing? Next one. I'm going to pick one out of that question 35. Nitrogen. Alright, nitrogen. Okay. Nitrogen's pretty straightforward. The formula is... What is the formula? It's N2, isn't it? Actually, I'm just thinking it's not so straightforward. Yeah. N2. Alright. So I'm going to do the structural formula first. Now, nitrogen has to form 3 bonds. 1, 2, 3. There it is. Okay? So it's a triple bonder. When we do chem sketch in a few weeks' time, you work out that a triple bond is shorter than a single bond in terms of its length. You work out in your head why that might be the case. Alright, so I'm going to actually now just lay them out. There it is. And I'll do the outer shell this time so you can see that it's a bit more complex, okay, for this one. Now, I've just said that there's 3 electrons that are shared. So if I use red for this one, it's got to have, over here it will be 1, 2, 3, must be overlapped. How many has nitrogen got in its outer shell? 5, 3, 4, 5. I've got to show all the outer shell electrons when I'm doing Lewis diagrams. So every outer shell electron has to be in the structure. Okay? Even the ones that aren't used in bonding, these are called non-bonding electrons. And I'm going to come back and I will show you the nitrogens over here. So this one here would have 1, 2, 3, 3, 4, 5. So that would be the Lewis diagram for nitrogen showing all the outer shell electrons. And again, if I cover it up, you can see that that nitrogen's got 2, 4, 6, 8, and that nitrogen's got 8 in its outer shell. So by that idea of sharing that we used last week, I'm sharing, but this time I'm going to be sharing 3 electrons, and then I'm going to be sharing 3 electrons back. Then they both get a filled outer shell. Okay? Anyone else? Any one of those in that question that you want me to go through? Ethane? Yeah. At C2H6? Excellent, alright. I was going to make some space.
Yeah.
So C2H6 you want to go through?
Yeah.
That's a bit more complex again. Got a few more structures in it.
Is that one or the C2H4?
I'll go through both. So C2H6, alright. And the C2H4 as well, ethene.
Yeah.
Alright. This one here. Yep. 1, 2, 1, 2, 3, 4, 5, 6. Now again, I've got to have the valency of carbon in my head, which is 4. Hydrogen valency 1. I'll lay out again where all the atoms are for this one. There it is. Okay. Now, I'm going to show all the carbon electrons. So there's 1, 2, 3, 4. That's the crosses for that carbon there. Okay, I'll use red for the other carbon. 1, 2, 3, 4. Watching code? So I've got rid of all the carbon electrons now. They're all accounted for, and they're overlapped in the middle because there's a bond in the middle. But now I've got to put the electrons in from the hydrogen. So there'd be 1 there, 1 there, 1 there, and 1 there, 1 there, 1 there. People always say, oh, I've had weird questions like this in the past. Can I do it like, does it matter if I do it like that, or if I do it like this? And I could show you all the variations. Can I do it like that, or that, or this? It doesn't matter, they're all the same. Okay? So it's showing me that 2 electrons are shared. It doesn't matter where they are. It doesn't matter whether you use crosses or circles or triangles or whatever you use, provided the electrons add up. Okay? You can see where they come from and where they go to, or where they're shared. Happy with that?
Yeah.
Alright, you want to do the C2H4 as well?
Yeah.
Alright, we'll crack on that one. So C2H4, you wouldn't know yet, but it's got an ene in the name, ethene. When we do that in term 4, that will have a double bond. So this would look like this. So it's the only way we can do the structure for ethene. So that's got a double bond in the middle, just make it a bit neater. Same deal, lay the structures out, lay the atoms around like that. Okay, and then I'll use, I'll say 1, 2, 3, 4, and you can see why I'm doing it because I've got 1, 2, 3, 4 electrons in the carbon. It helps me heaps to work out where they're coming from. 1, 2, 3, 4, that's the carbon electrons accounted for. And then I'll come back now, and I've just got to put in all of the 1, 2, 3, 4, and then we're done for the ethene. Okay? Okay, so that's what we're talking about when we do electron structure, electron dot structure, and structural formula. And that must be the end of the lesson.